Let's take a look at distinguishing between populations and samples. So a population is the set of all members or group that you're trying to get information from. It encompasses everything. It's the whole set. If we're talking about a sample is going to be like a subset of the population. So we have this example here. A school newspaper randomly selects 30 students from each grade level to participate in a survey to determine the opinions of students at the school. What is the relationship between the sophomores surveyed, all the students surveyed, and the students at the school? So in this example, it's the group of students that are the entire population. We're talking all of the students. Now, when we talk about a sample, that's that subset. So the subset here is going to be the sophomores who were surveyed. Now, keep in mind too, when we talk populations and samples, that doesn't necessarily mean people. I could have a population of all the lakes in the world, and then a subset would be the lakes in the United States. I could also word that as the population being the lakes in the United States, and then a subset could be the lakes that are found in Florida. B, a polling organization randomly chose eligible voters in the state of Illinois to ask who they would vote for in an upcoming election for governor to determine who will win the election. What are the sample and the population in this scenario? So here we're looking at all the voters in Illinois that are eligible to vote. That would be the population. The sample is going to be all of the people that were selected by the polling organization. Let's do some tries. And again, pause the video, read through them, see if you can answer them, and then come back and check. So a city worker collects 5 vials of water from each 10 randomly selected locations all over the city to test the levels of bacteria in the city water supply. What is the sample in the experiment? Well, the sample would be that 5 vials of water. The population is all of the water in the city. So population, all of the water, that subset is just those 5 vials of water. And now let's take a look at example 4. We're going to distinguish between parameters and statistics. So parameters describe a population. Statistic is a measure that describes the sample of the population. So a high school has 3 lunch periods. In a randomly selected period, 24% of students brought lunch from home. So that means the population is going to be the set of all students in the school. When we're talking about that 24%, that describes the sample of the population. So that 24% is a statistic. At the end of its first year of business, a movie theater collected data on how well its concession stand operated that year. The theater used its total yearly concession sales and number of tickets sold to calculate that the mean amount spent at concessions by a moviegoer was $8.14. Is this a statistic or a parameter? Well, our population here is going to be the movie theater, that particular movie theater. So that means when we're looking at that data that they collected, that data came directly from the population. Therefore, this would represent a parameter. And again, pause the video, see if you can answer these, and then come on back. Is the given data summary a parameter or a statistic? So 53.2% of a district's eligible voters voted for the sitting U.S. House representative. This would be a parameter because our population is the district's eligible voters. So therefore, this data comes from a parameter. B, the median age of a car in 20 randomly selected spaces in a school parking lot is 7 years. Now that word randomly kind of clues you off. If we're taking only, your population would be all of the spaces in the school parking lot. So if they're only taking data from a randomly amount of set of selected spaces, so that right there tells you that that is a subset of the population. You're looking at a sample. Therefore, your data is a statistic.